Okay, good morning, ladies and gentlemen. My name is Steve-Schmidt. I am the Chief Information Security Officer for Amazon Web Services. This morning, we are going to have a conversation about AWS and security. As we all know, security is not a binary kind of equation. It's not you are secure or you're not secure. And security as a word means a lot of different things to different people. So as a result, when we practice security as professionals, we have to approach it from a number of different viewpoints so that we can ensure that we get the information, the knowledge, the actions in place that are required to meet the different viewpoints and the different takes on things that our constituents have. Security itself is not one static thing. In fact, I'd argue that it's a continuum. It's almost this pervasive set of different shades of gray. You're never really secure or not secure. And security to me is something that's made up of both art and science. The art part is understanding how to balance the need to use, consume, store information, and make it available both to your customers and to your employees, whilst at the same time ensuring that you protect information that's important to your business and your constituents to the level that they require and they expect. You then have to couple that with the science of designing controls that help you meet those business goals, implementing them successfully, and then monitoring them to ensure that they're doing what you expect and your employees, customers, and others are behaving the way you expect. As Andy Jassy said, security is our #1 priority. And security to us is made up of the constituent parts of everything from human beings, what they have access to, how we permit them to have access to our facilities, our infrastructure, our network, but also the pieces of that that are really underpinning every single customer of ours operation. And that's down to things like the physical security of our data centers. Lots of you out there probably run data center security right now, so you know there aren't too many different ways to do locks and alarms, gates and guards, CCTV systems, et cetera. But they're foundational elements that have to be done absolutely right all the time in order for us to be successful, because a failure at that level can have serious consequences at the level above. Security is not just one conversation. It's a conversation between us as a service provider and many different customers. And that conversation has to take place in different languages that are associated with the customer's particular business type, the vertical that they're in, the constraints that they're under from regulatory pressure or customer demand, as well as the way they want to use information. We have to respond to our customers' requests for validation of our security posture. This is not a scenario where it's good enough to trust me, I'm doing this right. Customers have to have a way that they can ensure that what we're doing is consistent with their business goals and expectations. More importantly, we need customers to work with us on constantly improving security. This is a whole new world in cloud computing. There is not a standard operating procedure book that we can go to that we can say, to be correctly secure in the cloud, I will do A, B, and C. There are certainly guides that can help us. There are areas where we can focus more or less effort to achieve success. But this is a constant conversation. And one of the things we depend on is ensuring that our customers provide us constant feedback on what they'd like to see. And we'll talk a little bit more today about what that feedback results in and how customers can provide us with more useful information. One of the great things about working at Amazon is that every single customer does benefit from security enhancements we make. So when you get really large, focused companies like Bristol-Myers Squibb, who have incredibly tight demands on compliance regimes, for example, every other customer of ours benefits from that. We don't operate part of our infrastructure at one level and part of our infrastructure at another level. Everybody gets the same level of service. And that is tremendously empowering for a number of our customers. When you think about it, very few industries have the ability to hire numbers of security professionals, whether they be software development engineers or physical security specialists. So by having these really big guys putting a lot of pressure on us to raise the bar from a security perspective, it means that everybody who is a small or medium business, or heck, even the college student who's in his dorm room doing his homework using our free tier, gets to take advantage of the same security controls that we have for the biggest players on the planet. The result to that is that all of our customers get a shot at behaving the way the most demanding customers want us to. Now, NASA JPL is always pushing on us to raise the bar here. New features, new capabilities, new processes, and new ways to protect and understand resources. We'll talk about some of those changes that we've made recently that NASA's been driving amongst other federal customers, and how that can help you secure your operations. From my perspective, security itself is all about these three elements. Everything we talk about today will fit into one of these three buckets. It's about how you understand what you have, where it is, who has access to it, how you can audit that against your internal best practices or industry standards that you have to meet, and then how you can place appropriate controls on your access to services, your employees' access to data, your consumers' access to information, to ensure that that which you want to have public is, and that which you must keep private is also. The whole conversation starts with visibility. I believe really strongly that it is absolutely impossible to secure something if you don't know it exists. Now, that seems pretty basic to a lot of us, but when you have the conversation with people, especially those who have been in the IT industry for a while and have large on-premise installations, visibility is a challenge for them. They've often accreted these clusters of networks and systems over time, and the networks have grown organically from one space to another. And Bob plugged something into a rack 4 years ago, and nobody knows what it's connected to, but they're afraid to unplug it because it might bring something down. How, in that environment, can you reasonably place controls around information to ensure that which you want to have accessible is, but nothing that shouldn't be isn't? It's critically important that you know precisely what you have, where it is, who placed it there, what OS it's running, for example, the network controls around it, whether they're ACLs or security group settings. So by moving to the cloud, and this is something that Tom pointed out as a sort of a fundamental game changer for NASA JPL, is the fact that they went from an environment where they could do an inventory periodically, whether that's once a year on a good day or once every several years, to a situation where their security team can literally, every 5 minutes, understand precisely what virtual machines are running on their infrastructure, what the firewall rules are that are on every one of those virtual machines, whether the OS that's loaded on there was started from their approved gold image, and what networks they're connected to. That is a fundamental game changer for a lot of security professionals. It also has some significant benefit for compliance professionals. All of a sudden, they've got visibility into infrastructure that was never available before. An interesting side benefit that was also pointed out to us by a large client. They had compliance professionals who regularly would look at their network and understand what was going on. The problem was they didn't have a way to give them good access without giving them root privileges or administrator privileges. The net result was when one of the compliance staff made an error, it had operational impact. Because of the way AWS IAM is constructed, you can give auditors the ability to examine your infrastructure to their heart's content, but you can prevent them from making changes. So you can prevent them from making mistakes. Security does deliver more auditability, and auditability and compliance are associated. The interesting part of the follow-on to that conversation is compliance is not security. Compliance is establishing a minimum bar for operating an environment in such a way that meets certain security goals. Now, we are a global company. We have customers all over the planet. They have varying workloads. They're in differing verticals. And they require us to converse with them in their own language. The way we talk to our customers about security and compliance is to use common terms and common language. Those are expressed through our certification and evaluation process that results in audits and certifications. We have to address a number of different verticals. Andy Jassy talked about several of them in his keynote. They're up on the screen here. If you'd like to talk more about them, we're happy to later on. But the point is that we operate one unified set of controls across our enterprise and choose from them those that are appropriate to answer specific certification processes. That way, a customer doesn't have to worry about, well, this is a HIPAA workload, so can I put it in that particular set of infrastructure, or do I have to choose something else? All of our infrastructure operates at the same security assurance level with the same controls. Now, one of the most exciting things for me as a security professional, and no, my kids don't think this is exciting, but that's okay, is the introduction of AWS CloudTrail. CloudTrail is your way as a customer to understand with precision what your employees did with their AWS credentials on our network, what API calls they made, what resources they started and stopped, how they moved information around within your environment. CloudTrail constantly records those actions, and the actions are not only from you making API calls, but also, interestingly, from our services doing things on your behalf. So, for example, our customers ask that they be exposed to what we do behind the scenes to operate our services for them. We responded with that in CloudTrail. So an example there would be if you say, launch an Elastic MapReduce cluster. I want to do a big Hadoop job. You give us an API call to do that. We record that in CloudTrail and give you the log information. However, our service behind the scenes also launches those 1,000 EC2 instances that are required to do that EMR job. It connects them to a network. It provisions firewall rules on them. All of those actions are recorded, and we give you that information through a CloudTrail log. Now, obvious benefits from that. Security, that's a no-brainer. It gives you visibility into stuff. You can't operate well without visibility into your security posture. You can, if you wish, understand more about what's changed in your environment over time. But one of the more interesting pieces that came out of the private beta of CloudTrail was unexpected for us, and that's operational stability. We had customers who said that when they had an operational problem, one of the first things they do would be to go and look at the CloudTrail logs and see which of their employees changed what just before that operational issue popped up. Hey, that makes sense. So again, this is one of those situations where our customers really drive us to produce things that have fantastic benefits beyond our intended area. Now, obviously, compliance is an important part of security, and it's an important part of everybody's operations here. This gives customers the ability to answer compliance requirements, especially US federal government customers. Unlike a lot of compliance regimes where you have point-in-time snapshots of a network that you use for evaluation purposes, PCI, for example, a quarterly scan, is a point-in-time snapshot of what's going on in the network. The US government has a requirement to do continuous monitoring. CloudTrail can help them with that because of the frequency of delivery of log files and the consistency of that delivery process. So now the important thing about CloudTrail is that we record these logs for you, and we put them into your Amazon S3 bucket. The timing, obviously, about every 5 minutes or so, we aim for a 15-minute delivery interval for your logs. Now, an important thing here is these logs are being placed in your S3 bucket. If you use the ability of S3 to automatically move data to Amazon Glacier, you can keep these logs for a really, really long time at a very low cost. And customers say, well, you know, I'm used to rotating logs because my disks would fill up. You don't need to worry about that anymore. You're not going to fill up S3, though if you do try hard, we'll be happy. And the other point of that is I have yet to meet a security professional who could recreate logs that have been sent to dev null. And it's a real bummer of a conversation to be having with your boss when you say, oh yeah, we logged that kind of information, but it went away last week because the disks filled up. So take advantage of the opportunity to use the storage tiering that Amazon Glacier gives you. Now, a bunch of our partners, as Andy mentioned, help us understand what's going on with the logs that come out of Amazon CloudTrail. And the important thing here is the CloudTrail logs are information. They are not necessarily knowledge. So here to talk about how they turn our log information into actionable knowledge is Bruno from Sumo Logic.
Thank you, Steve.
There you go.
Thank you, everybody. So Sumo Logic is both a customer and a partner of AWS. We run our enterprise cloud log management and analytics service entirely out of AWS. And as such, we are entrusted with one of the most sensitive data sets on behalf of our customers. We constantly get questions from our customers that come in two forms. First, they ask us to improve their ability to understand and analyze their events in their infrastructure as they pertain to operational as well as security posture and policies. The second question that they keep asking us is to constantly improve how we handle our own internal security in order to provide better security, better privacy protection of their own internal data sets once those data sets move from their data center or their AWS infrastructure into Sumo Logic Cloud. So we are heavy users of CloudTrail information for both of those purposes. We provide this to our internal security teams to better understand what's going on with our own internal users as they touch and make changes in our production infrastructure. And we also, as a partner, are able to provide the same capability to other AWS customers who are interested in gaining a deeper visibility into what's going on with their own AWS infrastructure as well as beyond. So today I want to talk about, walk through a couple of very focused security use cases that we constantly keep hearing from our customers. So we built this integration, and in this specific view, we're showing a real-time view of and a visualization of user activity analytics as it pertains to this specific AWS account. We can combine this data set coming from CloudTrail with other data sets that can enrich this information and provide even deeper set of analytics. So for example, you can combine this data set with data from your Active Directory or LDAP to get a better understanding of who these users are. You can combine this with intrusion detection system logs, operating system logs, and other things to really understand what's going on. So in this example, we're showing how we combine the data coming out of CloudTrail, the actual IP address that comes with the user access, with geolocation information to understand exactly where are the users that are touching your infrastructure coming from. Beyond that, we can also isolate specific events that might be of interest to security teams. So in this particular case, we're showing the classic cover your tracks admin, malicious admin activity, where they're creating a new user, temporarily elevating privileges to that user, logging in as that user, performing some action, and then deleting that user to cover their tracks. So this is a classic insider threat visibility. You can also turn that around and look at it from the outside in. So here we're showing activity, actual successful activity, based on the CloudTrail logs from users that actually come, where that activity has come from countries where that are not home countries for the specific user. And in this case, George Harris seems to have had quite a few events that they've executed on this particular account from South Korea, whereas their country is actually United Kingdom. So this could be very much legitimate, right? People travel. However, it might raise red flags and you might want to investigate. So you go in a little deeper. So here we're showing, once you start investigating, what is this user? What's the pattern of access for this specific administrator, right? So on the right, you're seeing in green color events that this user executed from their home country, from United Kingdom, and it looks like they're doing things such as running instances, terminating instances, sort of very operational use cases. Whereas on the left, in red bars, are events that they have, or actions they've taken when they logged in from Korea. And so in this case, it looks like a very different set of access. So authorizing security group ingress, right? Creating network access, changing passwords and things like that. It might be that this user is trying to create a backdoor into this specific account. You can go even deeper, and I'm not going to go too deep in here, but you can go even deeper and really understand what are the things and actions that this user has performed within this account. So, here you can get access to all of the details, like what are they doing, where are they doing it from, on which instances, in which regions. But you can also see that, either this user is two separate users, or George Harris has access to teleport, right? Because he's logging into this account from two countries at the same time. So hopefully this gives you, a good high-level view into the art of the possible when you combine CloudTrail dataset with Sumo Logic Analytics. But if you want to see more, feel free to stop by our booth. We're in 117. We'll be doing a deeper set of demos throughout the week. And if you want to understand a bit more about how we are delivering enterprise class service entirely on AWS, please come see Christian Biedgen. He's our CTO. He'll be talking today at 3 p.m. in São Paulo. Thank you. Thanks, Steve.
Okay. Thank you very much, Bruno. I appreciate that. One of the things that we strive to do with the interaction with customers here is make these capabilities real. A lot of what you were just seeing focused specifically on taking a real-world operational request within a security organization and deriving knowledge about what your humans are doing. So how do we take that information and turn it into something that's actionable for security professionals? Understanding should that human be logging in from point A or point B, and turning information into action by saying maybe I should block that person or change their credentials, rotate, et cetera. Shifting gears from visibility into control, one of the themes that you'll see throughout this few days with AWS is we are collapsing security perimeters. In the old days, when we talk about human habitation, we would build cities and put walls around them. Hey, great, that's a wonderful way to protect yourself. The only problem is, of course, when the hordes breach the wall, they can run amok in the city, causing all sorts of issues for the inhabitants. The same is true of computer networks. If you rely on a perimeter defense system as your sole means of security, you can be in a situation that's unpleasant when somebody gets past it and is inside your walls running around. So back in the old days, of course, the more wealthy amongst us built castles with keeps and moats and things that helped them protect their own dwelling or their smaller piece of the pie. But that left the rest of us out in the cold, where we didn't have the advantage of those particular capabilities. The nice thing about operating in AWS is the playing field is flat. Every single one of our customers has access to the fine-grained controls that we give to the most demanding customers. You can choose to use them if you wish, or you can decide that they're not appropriate for your particular business. The collapsing of the perimeter takes place not only in the virtual machine and the network world, but it also takes place in the world of data itself. So for example, one of the requirements that some of our customers have had was to protect individual data objects to the level that met their particular business needs. So for example, you can create a set of rules for data objects in AWS that say only Tom may access this data object, and he may do so only when he is on the corporate network on his corporate desktop machine, and it's between the hours of 9 a.m. and 5 p.m. Eastern Time, Monday through Friday, and he's using a multi-factor authentication hardware token that he's been issued. There are very few on-prem environments when you can put that level of control around your information. So let's talk a little bit more about what are the major components that you can use to protect your information, or in the alternative, to enable your employees to do their job more efficiently. Identity and access management is our component that allows you to assign your individual employees AWS credentials and not give them root access. You can give them only the access to information that's necessary for them to do their job. Again, this is a major departure from the way a lot of people are used to doing business, where you say, well, this guy is a system administrator and he's got to be able to start and stop machines, so I got to give him an administrator account. Within AWS, you can say this guy is an administrator for this particular set of virtual machines, and he's permitted to start and stop those. But he can't touch virtual machines that are associated with another operational group. Amazon VPC allows you to construct your own piece of the AWS cloud. You can carve off a piece of our infrastructure. You can establish your own networks in there. You can lay them out with your own subnets. In fact, this is an interesting capability that was indeed built as a result of a specific customer ask. We had a financial services customer in New York City who came to us a number of years ago and said, I have 9 data centers. I want to close one. I want to take that and lift it into AWS, but I don't want to have to change the way I do business. And VPC allows them to do that. They can bring their own IP space. They can set up network ACLs that are identical to what they're used to using on premises. They can establish the packet routing between their VPC and their on-prem infrastructure, either over the open internet or over Amazon Direct Connect. Direct Connect, for those of you who aren't aware, is a service that you can subscribe to with us that allows you to establish a network link between our infrastructure and yours that bypasses the open internet. You can do that in 1 gig or 10 gig increments, up to your heart's content. The important thing there is it allows you to control latency and network path so you can meet your particular business goal designs. CloudHSM is a service we'll talk a little bit more about later, but it gives you an ability to store keys on our premises and ensure that our staff don't have access to them. Now, an important announcement that was made yesterday, I believe, is that we now support SAML 2.0 federation. So if you use Microsoft Active Directory, if you use Shibboleth on-premise right now, you can use that to federate your users with AWS so that we can authenticate your staff without having to have a separate set of identities for them maintained in AWS. You don't have to buy additional software in many circumstances. This is a pretty easy fit-in to your existing infrastructure. There is a new sign-in URL that has to go along with that, of course, so that we know to go and authenticate off of your infrastructure. But the important point is that this enables customers to use their on-prem identity stores to operate with Amazon Web Services. Another new feature is DynamoDB's fine-grained access controls. We've had some government customers specifically who say, I really like using Apache Accumulo because it gives me the ability to restrict access to individual cells in a database. You can run Apache Accumulo on AWS if you'd like, but DynamoDB also has the ability to do very fine-grained access control. This is particularly interesting for mobile product suppliers, where they can give individuals with their mobile device access to specific pieces of information in DynamoDB based on where that user is, based on how that user is interacting with their particular platform, or what user has authenticated or not authenticated to their mobile device. Most importantly, it gets rid of the need to put a proxy in between DynamoDB and that customer, so you can take advantage of the incredible responsiveness and throughput of DynamoDB. We're going to shift gears again, talking about control, and now talk about AWS itself. No conversation about security would be complete without helping you understand how we function as an organization, how it is that our staff are vetted, what we do when we give them access to infrastructure or operations. So to start off, as bringing somebody into the company, a new Amazonian joins us, we do background checks on all of our staff when they join now. A background check means that we examine their financial history, we look at their criminal record, we understand how they've behaved at previous employers and at their educational institutions. All of this is focused on ensuring that the people that we hire can be trusted to work with customer information. Now, when an Amazonian walks in the door, they get handed a corporate laptop or desktop and a set of credentials that allow them to authenticate to the corporate network. That does not mean, however, that they have access to the production networks that contain your information. In fact, every Amazonian who wishes to have access to your information has to be positively authorized by an appropriate person, usually their manager, to gain that access. And that access has to be renewed on a regular basis. So to give you an example, if I'm on the Amazon S3 team, and I'm a new software development engineer, I join the company, my manager has to say, this individual human, in order to do his job, has to have access to the following sets of machines that we call host classes internally. Absent my manager saying, I need that access, I won't get it. More importantly, 90 days after that access is granted, my manager must revalidate that access. And if he or she does not, it'll be automatically revoked. So this is a fail-closed kind of safety. Additionally, if I move to a different team within the organization, our infrastructure system automatically revokes my previous access, unless my new boss says, yes, he still needs it to do his job. Let's talk a little bit about how, as an Amazonian, I get access to the control plane for the services that you use. So EC2, as an example. If I'm on the EC2 team and I need to interact with the EC2 infrastructure for some purpose, I can't go there from my corporate desktop directly. I have to go through a control point. An example of one of those control points is what we call bastion hosts. A bastion host is a device that is specifically designed and implemented to enforce a second set of authentication and authorization. We do not permit our staff to use the same username and password that they use on our corporate network to access EC2. In fact, we don't allow them to use usernames and passwords at all. As you're probably aware, one of the most common ways for nation states to gain access and use people's infrastructure for inappropriate purposes is gathering usernames and passwords that are valid and then playing those back over the network using that opportunity to go in as the legitimate user and gather information. So we, quite a while ago, switched to a situation where we only allow certificate-based authentication. And in most cases, that certificate-based authentication has to take place using a physical hardware token, as opposed to using a soft token. As we roll out infrastructure around the world, that gives us the ability to ensure that even though the infrastructure is in a remote place, the human has to have that physical device in their hand in order to authenticate themselves. And it really removes a lot of the attack surface from the ability of bad guys to do unpleasant things to us. Getting into the physical security world, our data centers are one of our most precious assets. And we separate access from those facilities from everything else in the company, to the point where the badge that I use to get access to our headquarters building is not the same badge that I use to gain access to a data center. More importantly, the access control systems that sit behind that are not the same either. We don't even use the same badge encoding formats. We separate them completely so that we can ensure that the only people who have access to the data center facilities are those who absolutely must be in there to do their job. Fun little note, you ask most Amazonians where our facilities are located, they'll be able to give you a region of the world, they'll be able to give you a state, but they won't be able to give you an address. That's because they don't need that information to do their job. For those who do have access to our facilities, they have to have a separate set of credentials to get in, a separate badge system, a separate PIN, et cetera. And more importantly, they have to adhere to a set of requirements for control of information that they learn in the process of working in those facilities. Shared responsibility is about helping customers understand what it is that we do as Amazonians and the choices that the customer gets to have about what they wish to do with their information. As I said before, there are some things that are fundamental to the security of any operation, any business, anywhere. That's the kind of thing like the physical security of the infrastructure, the operation of the network, ensuring that when the air conditioners are called for in the data centers, they function properly and the power is supplied normally. On the other side of that is the customer gets to choose what operating systems that they use, how they install their applications, how they configure firewall rules or access controls on their networks. Because everybody's business is different, we have to give you knobs and levers that you can tune to fit your particular business requirements. An interesting note here, a question that I get asked quite frequently from customers who are more savvy is, you guys have a pretty big infrastructure. Andy was just talking about how every day you add capacity equivalent to when Amazon's a $7 billion business. There are a lot of hard drives involved in that, aren't there? And the answer is yes. There are a lot of zeros behind the number of hard drives that we have in our infrastructure. And as a result, when people talk about mean time between failure on hard disks, it's not a question of if a hard disk is going to fail, it is how many have failed today in our infrastructure. That's a lot of hard drives that contained customer information. Now, I believe very strongly that the best security controls are those that are simple. Simple controls are easily understood, they're more easily enforced, and they're more easily audited against. So we have a very simple control around hard drives. No hard drive may leave our facilities intact, period. That means, as a result, that we can't send things back for warranty repairs, but that's okay. It is much more important to us that we ensure that your data never, ever leaves our facilities. So what do we do with these big piles of hard drives that fail? If you're an engineer, it's actually kind of fun. Number one, if they're rotating media, the first thing that happens is we degauss them using an NSA-approved degausser, which is a big device that generates an enormous magnetic pulse and fries all the bits that are on the spinning disk. That's kind of fun. But what's more fun is what happens with that disk when it comes out of the degausser. We shred them, which means we break them down into chips that are about 1.5 by 1.5 centimeters square. Now, of course, degaussing works for magnetic media. It doesn't work for SSDs. And we've got a big SSD population. So what we do with those is we chip them down into very small fragments that are less than 1/4 the size of the smallest memory chip on the device itself. The result of that is it is very simple for our security guards to say, that is not an intact hard drive. It may leave. And we believe, again, that that's the critical part of success, is making it easy to do the right things. We also make it easy for customers to do the right things with their data. Many of our customers have specific requirements around where in the world their data exists, where it's placed, when it can be moved or not moved from one region to another. As you've heard, we have these things called regions. This is a sort of independent set of AWS services that aren't connected directly to our other regions around the world. The net result is that unlike some companies who do global load balancing or move your data back and forth automatically for you, we don't move your data out of a region unless you tell us to do so. More importantly, when you place an object with us, you must tell us what region that data object is going into. So you can't just say, store this in S3 somewhere on the planet. You have to say, store this in S3 in this region. The net result is that customers can meet PII requirements if they're in the European Union by storing things in our EUS data centers in Dublin, or they can meet US government requirements in the US by saying storing things inside the US, and we don't move it outside the country. Within each of those regions, there are availability zones. Availability zones are the equivalent of a data center. The reason I say equivalent of is because in our larger regions, one AZ may actually be made up of multiple physical buildings because they're so large. An availability zone is your building block for reliable, resilient infrastructure. You may have a situation where you say, well, this particular database is a dev test box. I really don't care if a meteor hits a data center and it goes away. So I'll put in one AZ. Whereas this is my production database, and I want to make sure that it's running in multiple data centers so that it can be available for my service all the time. And I don't mind spending a few extra pennies per hour to do that. So the point here is, again, that you have the choice to architect your infrastructure to meet your particular goals. No discussion on controls would be appropriate without a discussion on encryption. Why use encryption? Well, aside from reading the news and paying attention to what's going on in the world, there are a lot of good business reasons on why you use encryption as well. And those business reasons go everything from meeting regulatory requirements like HIPAA or SEC requirements for storing of information, all the way down to the best practices of, you know what, it's just a good idea to encrypt this information while it's sitting at rest. How do you do that? Again, it's the customer's choice. There are a lot of services where we do the crypto for you. Amazon S3, for example, has a server-side encryption option where it's literally you check a box in the console, and we encrypt all of your objects in your bucket. That ensures that even if our staff have access to the physical disks, the bits that are on those disks are encrypted. Oh, an important note, separation of duties. In Amazon, we believe really strongly that the people who have physical access to the devices should not have logical access to the content. So our data center technicians, the people who can actually go in and touch the disks, do not have privileges to operate at the logical layer on there. They can't log in as root on that machine and take an action. The corner case, of course, is, okay, this device is failing. I need them to log in as an administrator. In that case, we can temporarily grant them access to the physical machine if we so choose, but that action is logged and audited as a result. Why does that make sense? Because all of a sudden, we've removed a whole lot of avenues of access to stuff. I can't go in, say, ooh, that data is interesting in that particular machine, so I'm going to log in on the console and do something. In fact, our data center technicians don't even know what's on a machine. The level of knowledge they have about them is literally, this rack is an S3 rack. This rack is an EC2 rack. They don't know which customer's data is on what disk or on what machine. They couldn't find that information unless they went through somebody else. So separation of duties there is useful. Getting back to crypto. Customers can choose to operate using crypto where we manage the keys on their behalf, or they manage the keys using our services. So an example of that would be if you're running a database, let's say it's Oracle in RDS, and you want to use Oracle's TDE, Transparent Data Encryption option, which means the database itself is encrypted. So even our staff who have physical access to the disks on that database don't have access to the content that's within it. You can do that using Amazon RDS. And if you want to be the one who's in control of the key material, you can use Amazon CloudHSM to provide the key material to the database. Customers also can implement their own crypto if they want. You don't have to use anything that I provide. There are a lot of open source libraries that are available out there that provide encryption for Amazon S3 objects. There are a lot of options from our partners that provide you crypto for everything like EBS volumes on your EC2 instances. A little bit more detail about CloudHSM. CloudHSM is a service that we launched relatively recently that allows you as a customer to generate and use cryptographic keys inside an appliance that sits on our network, but our staff doesn't have access to it. Let me repeat that. We have physical access to the box, it's on our network, but we don't have access to the key material. Why does that matter? Well, number one, for some customers, they really just want to be in control of their own destiny. Okay, that makes sense. We're going to help enable that. The second is, we can't be compelled to produce something that we don't have access to. Interesting side note, CloudHSM was the only AWS service that was launched in Europe first. Customer demand. Lots of customers there want to be in control of their own destiny for cryptographic materials. So we provided them this particular lever. An important thing here, of course, is this is CloudHSM uses devices that are from SafeNet in this case. So these are certified and accredited devices that third-party laboratories have evaluated. It's not something you have to trust us on the function of. And the devices themselves are physically tamper-evident and tamper-resistant, meaning that if one of our staff for some reason decided to take the box apart and try and get at the cryptographic keys that are inside it, it actually erases the crypto material that's present in the device. Identity and access management is all about our ability to give you control over the humans or the machines that use your resources within AWS. So this means that you've got the ability to create access controls like I talked about earlier on individual data objects. It also means that you can assign your users, your internal customers, the minimum set of access rights that they need to do their job and not more. You know, it's tough to have a situation where somebody makes a mistake and deletes a whole set of virtual machines that they really didn't need access to. You can prevent that through appropriate use of IAM. Additionally, we give you the tools necessary so you can use your on-prem identity stack to drive AWS. That's a real game changer for a lot of folks who were concerned about, well, you know, what happens when Joe leaves our company? You know, how long does it take me to go and reduce and remove those credentials from AWS? If you're federated, it's something that happens for you, as opposed to you having to go in and do something independently. MFA-protected API access. For those folks who are really, really, really concerned about meeting regulatory requirements, the financial services industry, particularly, for example, has requirements for record retention that say only an appropriately authorized record retention officer may delete this set of information. We enable that use case. You can have a physical hardware token, or you can use a smartphone with a soft token if you so choose, to operate AWS MFA, and put it into somebody's hands with the knowledge then that even if somebody else has their AWS credentials without that physical token, they can't take actions, or in the alternative, only can they take actions when they have that particular token. Bunch of documentation about this area. This is a really, really rich field for controls development, so please take a look at the documentation. There are also some additional information sets that we'll talk about later on that are coming up during presentations. At this point, I'd like to welcome up Christian from Entersekt, one of our customers, who's going to talk about their use of CloudHSM.
Thank you. Hi, everyone. I'm Christian Brand, the CTO for Entersekt. So Entersekt is all about providing secure multi-factor authentication without sacrificing on user experience. So we're offering an easy-to-deploy PKI-based solution to allow our customers to mitigate the risks that's associated with authentication through technology endorsed by financial regulators around the world. So as soon as an organization needs more assurance than simply trusting a username and a password, they can relay that authentication payload through to what's called an Entersekt security gateway on their premises. That in turn will send a message to an associated smartphone. That message is completely encrypted, utilizing AWS really as part of a smart message router. Now the important thing to remember here is that all of the data payload and the transactional information that's sent through the Entersekt security gateway to the phone is sent in a completely end-to-end encrypted state. So when the user enrolls for the service on the phone there, a unique public-private key pair gets minted directly on their phone, and a certificate signing request gets generated on that device. Now, CloudHSM is then responsible for signing the certificate signing request directly from within that FIPS 140-2 compliant environment. So Entersekt, as you can see there, utilizes EC2 for elastic scaling, Route 53 for DNS, RDS for high availability database instances, Elasticache for availability across different nodes, VPC, and of course, last but not least, CloudHSM. So CloudHSM, as already said, allows us to issue these X509 digital certificates directly from within AWS, while still maintaining the strict security guidelines of having discrete hardware security modules in place. And most important, I think, is only we have access to that key material that's stored inside CloudHSM. We also know that phones are particularly bad at generating entropy, and randomness is one of the key cornerstones of cryptography and of basically key material and key generation. So CloudHSM allows us to augment the entropy or the randomness generation on that mobile device. So all mobile device connections are really fronted as they're connecting in by the AWS cloud, and this allows us and our clients to mitigate distributed denial of service attacks, manage a large number of persistent TCP connections coming into the infrastructure, all while still maintaining that very, very important end-to-end relationship between the phone and that piece of hardware running on the bank's premises. So up until CloudHSM, we had to run discrete data centers which housed our online certificate authorities. But since the introduction of CloudHSM, that allowed us to move all of that into AWS while still ticking all the regulatory mandate boxes. So here's a brief overview of one of our global top 500 banking customers using our technology for online banking authentication. On the left, we can clearly see the number of phishing attempts they experienced in blue, with successful fraud as a result of that, actually they're in red. After our product was introduced, and you can roughly see there just before the weekend of the 22nd of March last year, phishing simply dropped away. So Entersekt's technology is also certified for use as part of the protection of online card transactions, the 3D Secure Protocol, which some of you might know, by Visa, MasterCard, and American Express. And you can also test drive our technology yourself as part of our initiative with LastPass. So let's look at a brief little demo of the solution. Here's a little video that I've recorded last night, which shows you the technology in action. So there's a user trying to sign into online banking. He goes ahead and enters his very important username and password as that first factor. When he supplies that, the bank does a step-up authentication, which results in a message being sent completely encrypted to his mobile phone. At this point, that private key will be used to decrypt the data. Once I click OK, a digital signature will be created, sent all the way back to the bank, and I will be signed in. And you'll see it's multi-factor authentication, all without using a one-time password. Here the user goes and tries to do a transaction again on the bank. The bank will deem this transaction risky, so they will initiate step-up. And as soon as step-up authentication then gets initiated, again, a completely encrypted data payload will be sent to the phone. At this point, I will reject it, just for the sake of the demo. And once I click reject, immediately a negative digital signature will be sent through, and the transaction will be stopped in real time. Thank you very much.
A lot of what we've discussed today has been about the nuts and bolts of how you should examine security within AWS. But the overriding theme is that the proper application of the controls that we enable can enable you as a customer to be more secure than you can be on premises. You can have better visibility. You can have better auditability. You can have more fine-grained controls over your information and your data. The net result is that you can run your business more efficiently and focus on those areas that differentiate it from your competitors, as opposed to having to worry about whether or not you're meeting particular security requirements. The nice thing is that a lot of your colleagues agree. This just came out. And we've got a set of talks that you need to see for the next few days. I would suggest that not only do you take a look at this particular selection, but there are pieces of this that are going to be pretty unusual and pretty different from AWS perspective. The last one that's on the list is all about Amazon VPC. If you're using Amazon VPC now, or if you're interested in using Amazon VPC in the future, this will be the first time that we talk publicly about how the guts work. This is all about literally how we decide to route packets, the security controls wrapped around them, how we manage the infrastructure on which they ride. So it's going to be a really interesting conversation. Let's suggest that you take a look at that if you're on the techie side there. You can see it's a 400 level, so it'll be pretty deep for those who are interested. 205, Sec 205, by the way, is a customer presentation. This is not us. This is about one of our customers talking about how they have made their organization more secure when they switch to AWS. So if you'd like to be in the same place, please take a look. Now, if you'd like to talk to some of our staff about security, please come visit us in Toscana 3605 on Thursday between 4 and 6 p.m., or the AWS booth itself. Now, the URL on the bottom of the screen, of course, is our security landing site on the AWS homepage. Off of there, you will find a huge number of resources for you to help design and implement security appropriately on AWS. We have a brand new version of our security white paper that's located off that site. Please take a look. We've substantially changed it from the last revision. It contains lots of more interesting, useful, in-depth information about our newer services. It also contains some pointers to best practices, so that if you wish to implement your services on AWS consistent with what we think is the right way to do business, take a look at that. Last but not least, we need your feedback. So we need your feedback about what you like, what you're interested in, what we could focus more on. So please provide it both through the formal feedback tool or directly to any AWS staff member. You can identify them by their gray T-shirts that say AWS team on the back of them. With that, thanks very much for your time and attention. Appreciate it.